Let's go over the fourth principle now, which is the integration segregation principle. Now, this principle states that no class should be forced to use something that they don't need in the first place. This just adds dead code. Now, for example, here we have a order processor class which implements process order, calculate shipping, and adding a gift wrap. This is a order processor class. Now we have multiple types of orders. For example, we have the regular order, and this inherits the order processor class now. And we will now have to implement process order, calculate shipping, and add gift wrap. Another kind of order is the international order. We'll again implement the same things. And the third one is the gift order, which inherits from order processor again. It implements the three specific methods. The usage is, for example, for the regular order, we will instantiate the regular order class and we'll call the process order function. And finally, we'll calculate shipping. For the international order, we'll again process order and calculate shipping. And for now the gift order, we will process this order. This is the additional part. We'll add gift wrap and we'll calculate shipping. Now, if we take a look at this point, the adding gift wrap part is only called in for the gift order. The international order and the regular order do not have the option of adding a gift wrap. However, if we look at this piece of code, the regular order is forced to implement this add gift wrap method because it is inheriting from the order processor class. It's the same thing for the international order. It is forced to implement add gift wrap even though it is not using it. Now, these are the drawbacks of this code. This integration segregation principle, again, it states that no class should be forced to use something that they don't need in the first place. So we'll have to refactor the code according to this principle such that international orders and regular orders do not have to implement add gift wrap method in their signatures. This just introduces more dead code here. And now how can we do it? Let's separate the concerns here. We can create an abstract base class now for if the order is processable, if the order is shippable, and finally, if the order is gift wrappable. And we can add those individual methods inside these interfaces. And now we can build a regular order. The regular order can only process the order and calculate shipping. And that's what we will inherit. Those are the two classes that we'll inherit. Similarly, for the international order, we'll inherit only the processable and shippable abstract base classes. For the gift order, however, we will inherit processable, shippable, and gift wrappable abstract base classes. This gift wrappable abstract base class is inherited so that we can write the function for add gift wrap. The usage remains exactly the same here. There's no change. The only good thing now is that the international orders and regular order, they do not have to implement a function that they don't really need in the first place. And the code is cleaner. The interfaces are very small and they are to the point. So we have separated again concerns. And then finally, we can add multiple types of orders in the future if we want to ever add them. This makes our code extensible and much more cleaner and maintainable. This is an example of a builder pattern. And then finally, unit tests writing are easier. Now again, is this the best way? In this particular example, we have not followed composition over inheritance. The above code leads to a lot of base classes that might still be somewhat difficult to debug and test. We can of course fix it, but just for the sake of this example, I wanted to illustrate that this could be a real issue. Another thing is that we now have n number of interfaces. We really need to ask ourselves if, based on the status and size of the project, if more interfaces are truly needed here.